somewhere deep in the Smoky Mountains.
Alert the commander, we've got a code red.
A mysterious new fossil found deep in a South African cave.
Quick, find our best scientist for the job. Attention, Mark. We need you in South Africa.
I'm on my way.
Be right there.
Game on!
Got it.
Heading back.
Our heroes arrive ready for action.
My sensors tell me it's behind that rock wall.
But how do we get through?
I know how. With robotics, RZ-1138 dig us a hole. If this hole gets any larger, this rock will collapse.
I can't fit through that.
Me neither.
Not a problem. Leave it to us.
RZ-1138 decides to join the search party.
I don't see anything.
Wait! Over there! Could it be?
Let's find out. Time to dig.
Hours pass.
No response. Where could they be?
Look!
We did it! We brought the fossil!
And leeches. Don't move. This is a rare Ornithodella edentula. I thought these only lived in New Zealand.
Yikes! Get them off me!
Don't worry, they're quite harmless. Look.
HQ wants that fossil and these leeches for some top secret test up at the space station. I've got to head back. Pronto! See you guys on our next adventure!
And so the team returns home, waiting for their next adventure. It's all in a day's work, when your work means having some very
Cool jobs!
Woo! All right, welcome everyone! Wow! Look at this crowd. Awesome. Well, welcome to Cool Jobs here at the Skirball Center. You got a little taste of some of the things that you're going to see in just a little while. And are you guys enjoying the day so far? Is this an amazing event? Enjoying it? Wow. Wow. I'll tell you, the only thing better than a beautiful, warm spring day in New York is a warm spring day in New York with science. So you're going to meet 5 really amazing scientists today that do a really wide variety of work today. And if you happen to be one of our young people in here, I want you to not only listen to their stories and the amazing work that they do, but also I want you to think, how can you see yourself in a role in science? I want you to listen to what they say and think, wow, what would I like to do? Is there a way that I can get involved in this? Because when you think about it, you're a kid. You play in dirt, you climb trees, you build little model rockets, and if you become a scientist, you get to get paid for doing all that. So that's a good deal. All right, now how many of you guys play some video games? Video games, you video game people? All right, I got a little confession here for you. You know how you play a lot of video games and your parents are like, stop playing all the video games? Well, our first cool scientist actually found his passion through video games. He started playing sorry parents. Started playing video games, kind of got inspired by all of that programming, and he later went on to build some robots, and we think that they are going to be the robots of the future. So please welcome our very first cool scientist, Chad Jenkins.
Hi. Before I introduce my dad, let me introduce myself. I'm Morgan Jenkins, and I have grown up around robots. Why? because my dad has a cool job. You could say that I have been working with my dad for over 10 years. From a very early age, we had a lot of robots around our house. My brother and sister have been hanging around robots since they were little too. The robots we have in our home are pretty small, like the Roomba vacuum. When I was much younger, I could vacuum up my own crumbs using the Roomba. Of course, my brother also liked to follow the Roomba around the house. When my dad brought home the Roomba from the lab, we took it outside and made it follow me using an AR tag. An AR tag is a square with black and white symbols on it. The robot can recognize it and then follow me. Here, another robot is able to follow my sister without an AR tag. Sometimes it looks like we are the ones following the robots around, but really, that is just because the robot has been programmed to keep a safe distance. My dad uses Hooke's law to make sure this happens.
Did somebody say Hook?
Not that Hook.
Oh!
We are lucky that my dad gets to bring home some of his work for us to see. But when I go to my dad's office, that is when I get to see the big, cool robots, like the PR2. But we have to be careful because the PR2 costs as much as some houses. One time, we helped the PR2 build block towers. I have also seen the PR2 deliver sodas from one place to another, which I think everyone would want at their house.
Hi, Morgan.
Hi, Dad. I'll let you take it from here.
Thank you very much. So, hi, my name is Chad Jenkins. I'm an associate professor of computer science at Brown University, and I should note that's the same Brown University that strikes fear into many a parent's savings accounts. But at Brown, I actually lead a great team of students and researchers where we get to work with some of the coolest robots on the planet and beyond. These robots can roll, walk, fly, run, grab things, follow people, deliver, but still can't do most of what we want them to do. And our job is to write more and more sophisticated computer programs that allow robots to do more for people, to do the things we want them to do. But this isn't just a cool jobs talk. This is a recruitment talk. We actually need your help to make robots a future, robotics a future for reality for the future. And so we need you to learn how to program just like us. And so we're going to try and get you to program through this talk. So when I was a kid, like Morgan and like many of you out there were no robots, and robots were purely science fiction. Not only that, there were no computers or video games either, until the day my parents changed my life, December 25th, 1981, when they brought home this, the Atari 2600 video game console. Yeah. With the Space Invaders cartridge. So even back then, we hooked up to a TV set like you do now, but most TV sets back then were only black and white. We didn't necessarily have color. But I spent a lot of my time playing video games like this. I spent endless hours doing this. These games might seem simplistic or even lame by today's standards, but it was totally cool for 1981, and just scratching the surface of what we could do today. And so I played games like this one too. So this is Kaboom. I played a lot of that to the detriment of my grades and other things. And so I just was fascinated. I was awed by these games. And so if you flash forward to today, so 30 years later, when I actually have a real job, I can actually make those same games. So the games that my parents used to go out and went to Sears and paid $30 for, are the games that I can now make myself within a day or two. And I can, not only that, I can share them with people. I share them with Morgan. I waste the time of the people in my lab by sharing these games with them. And I could do that all on my own. And the question that you should ask yourself is, how did I get to this point? Well, I got to this point through having a great education. And that education is represented by the books that are on my bookshelf. And so I essentially learned computer science, which is how I learned how to program and understand how computers work, math and physics, which lets me make games that move and look realistic. just like it does in the real world, or at least something that's believable enough. A little bit about electronics, so I understood how computers worked at their lowest level. Computer graphics, so I could make interactive 3D worlds. Computer vision, so I could enable robots and computers to see things in the real world. Oh, computer vision didn't show up. There we go. And robotics to make machines move in the actual real physical world. So using this knowledge, what I was able to do is make my own video games and technology. So as a student, what you're seeing is an early project that I did was I just made a virtual baseball game. So I could see the world. Had immersive head-mounted display that let me see the world. So it was an image projected directly on top of my eyes. I had a bat I could swing, and so it was a real immersive experience. It felt like I was actually swinging the bat. We made a racing game where we could drive the car by essentially moving our hand in front of a camera. That may seem believe it or not, that was state of the art for 1997. So now we have Wii's and Kinects, but that was a big deal back then. We took that system even further to be able to not just track the hand, but even track the body. So we used the tracking of the body to control a physically simulated humanoid robot. And then we took that system even further by enabling a person to control a robot, a real physical robot, directly using their body. And so what you're seeing right here is Nathan controlling the NASA Robonaut. So an early version of the NASA Robonaut. Robonaut version 2 is actually on the International Space Station right now. But you can try to move like the robot if you want to. It actually makes a really interesting dance. Not like the Dougie, but kind of like the Nathan, which is kind of cool. But you could think of those little devices on his arms as sort of like Wiimotes before there were Wiimotes. We wanted the robot to not just copy your motion, but actually be able to interact with you like a partner. So we basically had systems that could now track you and then could see and recognize a person, and then we'd use that recognition to be able to have a robot follow a person. And we essentially used, as Wesley stated, Hooke's Law to be able to do this. And so that was really great when quadrotor helicopters started to become really, we could start to buy them off the shelf, and we could use them for our regular research. And so what you're seeing here is Evan with the AR drone. And so what we're able to do is there's a frontward-facing camera on the robot, and it can see an AR tag, which is called an augmented reality tag. And from that camera, we can essentially have the robot follow that person. And so we want to show you just a quick little programming demo of it because we want you to be able to do this for yourself. But before we do that, I'll just have a quick reminder while we have the talented and lovely Alice come out and help us with the programming demo and get our volunteer. One thing that you should always be aware of when you're using robots is to be careful around them. Robots are fun, but bad things can happen, like that. So just be careful. And with that, I will hand it over to Alice.
Great. So can we have a volunteer from the audience? Great. So what's your name?
My name is Simon.
Simon? Thanks for being willing to help us today. Stand right here. So what you're going to help us demonstrate is the simulation of a drone following an AR tag. So if you take the mouse and click on the AR tag and drag it around, and drag it all over the screen. Great. So we see how the drone is following the AR tag. And it follows at a set distance as if it's connected with a virtual spring. So you see if you go toward the drone, it backs up, you go away, and it will follow. Great, so the program that makes this happen is going to be available to you. I'm going to show you. There it is. So on the left side, that's the code, and on the right side is the drone and the AR tag, and this is in JS Fiddle. So go ahead, you can move it again. So these are the same settings as the first time I showed you. Now what I'm going to do is show you that we can change the properties of the spring. So first we're going to make the spring stiffer. So we're going to make this from 0.05 to 0.5. And then click over here on Run. So now let's see how the stiffness has changed. Great. So now when we move the AR tag, the drone acts like it's connected with a rigid spring, a really stiff spring that doesn't stretch hardly at all. So now, we'll change the rest distance. We'll make the drone stay farther away. Click Run. So there it goes. So again, this is something you can do at home. This is, you can just open it up in your web browser. Thanks a lot, Simon.
So how did that demo work? So they were changing all sorts of parameters, but what did those parameters mean? Essentially what we did was we programmed a virtual spring into the controller of the robot. What that virtual spring does is it makes sure that the robot stays the appropriate rest distance away from the AR tag. That rest distance essentially is equivalent to the rest distance of the spring. So if I have a spring right here, so the rest distance is the length of the spring when it's not being pulled on or pushed on, right? And so we put that, so that what the controller does is put that spring right there. And so if the person gets too far away from the drone, essentially what happens is a restorative force comes and pushes the drone back, pulls the drone back to the safe rest distance so that they can be close, so the drone can follow. If the person gets too close, which isn't very safe, essentially we have the spring pushes back out and brings the robot back to the safe rest distance. And so that essentially is what we do to program robots using Hooke's Law.
Did somebody say hook?
Not that hook.
So Hooke's Law actually isn't that complicated. So it actually just says that the control force we have, the force that pushes the drone forward or backwards, is equal to -1 times some number that Alice was showing that represents the stiffness of the spring times the distance the robot is away from its rest position. And because science is really about doing for yourself, right? You should never trust anything anybody says unless you can do it yourself. Tau is a good time to figure out to learn how to program because that can be very easily programmed in. And we're just going to show you a few quick examples of that. And so earlier last week, Morgan just sat down and said, here's Hooke's Law, and she just programmed it into Scratch. So many of you may be familiar with Scratch. That program is everything that you need to do to have essentially the Scratch cat follow your mouse cursor. Also, the drone simulation that we had, as Alice pointed out, is available on our website, programsfor.me. And also, I wanted to just finish up by saying that we want to reemphasize that you don't need the AR tag, right? You can have the robot essentially follow you by recognizing where you are, and we're just using a regular old Microsoft Kinect camera. And that camera is being used to follow Ling Zhu around, as you saw in that video. And I think that's a really amazing video. I think you should pay a lot of attention to that video. There we go.
PR2, can you stop here?
One more time.
Can you stop here?
Waiting.
Thank you, Ling Zhu. Just to reemphasize, science is about seeing for yourself. Never trust a video. And so I think that just sort of highlights what we can do. So what we're aiming for is by the time Morgan is my age, that we actually make robots a reality. The robots are no longer purely science fiction. Robots are real and they're here today, and what we're trying to do is trying to find new ways to make robots more useful for people. And you are the future scientists, engineers who will make the breakthroughs and develop the technology that we will all use in the future. Someday, robots like the PR2 will be as common as computers, and we need your help to make that future a reality. What makes my job really cool is I get to help you make that reality. And so what we need you to do is be able to learn how to program. All the examples that we have are free, available for you to use, learn from, do it better, and show us how we can make robots a reality. And so for myself, Morgan, all the people in my group, we want to really invite you to come be one of us and help science move ahead and make robots a reality. Thank you very much.
Awesome. Bye, robot. Was it me or was he talking about mind-controlled robots? That's cool. So yeah, you guys get to build these robots. That's pretty cool. and imagine what they will be doing. We might be at a point, like you said, there's no longer science fiction. They're actually there. Now, I know what you're thinking. Thinking, yes, robotics are cool, Science Bob, but quite frankly, I'm a little more into really weird parasitic blood-sucking worms. Right? Kids, we got you covered. We have another scientist who goes out into nature and uses his own human skin to track down his study subject. Please welcome the leech guy, Mr. Mark Siddell.
Well, it's great to be here at the World Science Festival. Are you all having fun? I have a pretty cool job. My name is Mark Siddall. I'm also known as the leech guy. I'm a curator at the American Museum of Natural History on the Upper West Side of New York, where I work on leeches, and I work on a lot of other invertebrates, and I work on parasites. You might be wondering how I got to be the leech guy. Those of you, by the way, who have been to the museum recently may have seen one of my exhibitions, which is The Power of Poison. How many of you have seen that? And we have a book that's come out in relation to The Power of Poison, just came out this week, and illustrated by my charming wife. You may wonder how I got to be the leech guy. It turns out that there is a word in almost every language for leech. And yet when I started doing this back in, say, the late 1980s, early 1990s, there were only about 3 people working on the biodiversity of leeches. When I get towards the end of my presentation, you'll get a sense of how I sort of stumbled on becoming a leech expert. Most people think about leeches as being these black, slug-like worms that are lurking in dark waters and will come out and suck your blood. Well, if you look at those leeches really, really carefully and concentrate, you'll actually see that they sometimes have very beautiful colors, like these orange polka dots going down the back of the North American medicinal leech. It also has a beautiful orange belly, and we study the diversity of leeches from around the world by looking at some of these color patterns and looking at their internal anatomy. Now, medicinal leeches, like the North American medicinal leech, Macrobdella decora, have 3 muscular jaws inside their mouth that have tiny little denticles or teeth with which they actually make an incision in your skin, from which they then feed on the upwelling blood. The circular sucker in the mouth plus the teeth marks leave you with a beautiful Mercedes-Benz mark, very prestigious. And it turns out we actually have some North American medicinal leeches with us. I'm going to draw a name from the audience at complete random. Is there a James Danziger out there somewhere? James? James, why don't you come up here? Okay, James, these are North American medicinal leeches. Do you think you can get the lid off with me? Okay, I just put that aside. Why don't you have a seat in the chair? Can you roll up your left sleeve? You don't want to do this? Okay, well, why don't you come over here then, and we'll get Michael Tesler, my graduate student, to help out. Could you hold on to that? We might need that. Michael Tesler is a graduate student at the Richard Gilder Graduate School at the American Museum of Natural History. Michael, are you ready?
Oh, I'm ready, yeah.
Okay. James, could you take Michael's arm and stick it in that jar of leeches, and don't let him take it out.
Ah.
Now, we'll see how long that takes for those leeches to start feeding. It turns out leeches are actually beautiful animals. These are some marine leeches. Some of these feed on marine turtles. Some of them feed on sharks. Some of them feed on other marine fishes. They're really quite beautiful to behold. Other leeches, like the European medicinal leeches, we have Hirudo medicinalis on the left and a relative on the right, have beautiful color patterns. And some of the things that we're looking at in terms of biodiversity and evolutionary biology also concerns how they manage to prevent blood from clotting and how that's evolved over time. And invariably that involves proteins called anticoagulants in their saliva. Some of them prevent platelets from clotting. Others, like hirudin, which is one of the most potent antithrombin compounds, can keep you bleeding for up to 12 to 24 hours after a leech feeds. This little mess here is from the European medicinal leech. And James, if you would come over to this side and open this jar. Can you get it? There we go. And would you please hold his arm in there very forcefully? Don't let him let go. Okay, that's great. Michael, are you okay?
So far, so good.
You don't feel anything?
No bites yet.
Okay, well, hopefully we'll get a good bite by the end. Let's all give James a hand. Thank you, James. The European medicinal leeches were given to us courtesy of Leeches USA. Yes, there is a company out in Long Island called Leeches USA. Leeches are still used for medicinal purposes, mostly involved with reattachment of digits and other things in terms of microsurgery. This is what we do in order to collect leeches in the wild. We go usually to a fairly remote place where there's water and where we hope there are leeches. We roll our pant legs up. We take our shoes and socks off, maybe wear sandals, go wade into the water up to knee level or go wander into a jungle barefoot, wiggle our legs around. The wiggling is actually really important because leeches can detect you from many, many meters away. They don't need to be this close. Anything happening yet?
Not quite yet.
Okay. That's the giant Amazonian leech that is on my leg in French Guiana. Every once in a while, we take our legs out of the water to see if we have anything on. It requires a lot of balance. And then we pick them up and look at them and put them in jars. While we're in the field, we spend a lot of time talking with the local people and trying to get them to understand what we're doing. And the reaction is fairly universal, yes. There are some dangers associated with wading around in water on various continents. I'll just allude to some of them with pictures. Anyone want to go camping with me? I'm sorry, you may want to avert your gaze. Leeches do get into some strange places. I'll change that. And we got notification from a colleague in Peru that there were these children in the upper reaches of the Amazon that were all getting leeches up their noses, and it was very painful. And they sent us this leech, and it was a leech with the largest teeth ever. This is the endoscope going up the nostril, and you'll see the leech at the very end there hanging onto this poor child's mucous membranes. So I'm not going to get you with leech conservation, am I? Okay. Well, there was a leech with the largest teeth ever, and it was harming people in the Amazon, and so we gave it the name Tyrannobdella rex, so that we could say T-Rex is alive and well feeding on children in the Amazon.
Just started feeding on me.
The Gerudos just started feeding on him. Fantastic. Is it hanging on?
We got one on my hand right there.
Excellent. So Michael's favorite leeches are the terrestrial leeches. Is there anybody from Australia out there or from Southeast Asia, the Philippines? In those places, leeches are actually more often terrestrial than aquatic. And there's a bunch of them up in here. They're really, again, look at how pretty those are. I mean, seriously. Now, there's some interesting things that you can do with terrestrial leeches. Some guys in Denmark went out to Vietnam and they said, you know, we can't actually go out and shoot all of these mammals that we want to figure out what, by shoot I mean photographically, all of these mammals where they want to figure out what the diversity is and what the habitat is like and what their ranges are. And they came up with this great idea. Why not just collect all these terrestrial leeches on the ground, cut them open, take the blood meal out, and then DNA sequence the blood meal and find out which of the rare and endangered species are in the same place, because that's how the leeches would have got the blood. Well, so to give you a sense of how this all started, I actually grew up with a beautiful ravine across the road from the house that I grew up in. This is a very early picture of me in Canada. Thank you. This is a little later picture of me. And like a lot of the 9, 10, 11-year-olds out there, I was really interested in science when I was young too. And this is actually, I did the science of maple syrup. That was my first science project for a science fair in class. When I got to high school and graduated high school, I thought, oh, I'm going to be a physician. I was really interested in natural sciences, and I wanted to be a medical doctor. When I went to college, on the other hand, I got the opportunity to do some blood parasite work with a professor at the University of Toronto who was doing blood parasites of frogs and turtles and marine fishes. Now, these are very much like malaria-like parasites, but of course, marine fishes don't have a lot of mosquitoes biting them out in the wild, and it turned out that leeches were the things that were transmitting those parasites from one fish to another or from a turtle to a turtle. And I just accidentally became a leech expert because I was studying all of these leeches to find the blood parasites that I was working on. Now, since then, I've done a lot of expeditions for the museum. This is just one in the Bolivian Andes. Prior to going to graduate school, this was the amount that I had traveled around the world. I had traveled across Canada, and I had been to England once. How are you doing? Feeling faint?
Okay, yeah.
Not feeling faint?
These guys are pretty good biters on the right, yeah.
Feel free to exclaim, ow. But since then, this is how much of the world I've seen as a biodiversity expert. This is a really cool job, honestly. Now, and all of that because I study leeches. And there's only about 700 species or so. Now, one of the things that I'm also known for, besides just studying leeches, is I have a great affection for food. It probably shows a little bit. Nova, in Nova Science Now, has this online program that they've done. You should go check out. It's called The Secret Life of Scientists. And I was one of the very first ones to do this. You get to see all these scientists, and what else do they do? And for me, it's something that I call expeditionary gastronomy, which means that wherever I go in the world, this is in Belém, part of Iquitos in Peru, I always go to the markets and find whatever crazy food. Well, this isn't crazy food, that's just normal food. But you'll find strange fruits to eat. You'll find strange animals to eat. This is in Incheon, China. There's about 5 different phyla in that bucket, and it's all there to be eaten. Some kind of mystery meat that I never figured out. These fish were actually really tasty, and instead of pigeons in the market, those are actually vultures running around on the ground, taking the place of pigeons. In Peru is where I first got the opportunity to eat beetle larvae. These guys are great. When they roast them up, they taste like popcorn with melted butter on them. The silkworms in Korea actually taste a little bit like sweet peas. Yeah, octopus sometimes sauces itself. So I've often been asked, because people know that I'll eat just about anything if it's put in front of me, have I ever eaten a leech? And the answer is yes. I roasted it over a fire, and so I can tell you it tastes a lot like charcoal. And the most common question that I get from people is, how do you remove a leech? And my answer is always the same. Let it finish. Thank you. How many?
I got 3.
All right, let's get them off. Oh, dude. It's kind of like getting chewing gum off your shoe on a hot summer day, because they hold on with both ends. All right. How'd we do? Oh, geez, more?
Not too much blood yet, but it'll come.
There we go. Do you need this? Thanks, Michael.
Mark Siddall, everyone! Wow. So I learned 2 things. One, leeches are pretty cool. I was thinking about maybe a puppy, but no, I'm totally going with leech. And 2, think twice before becoming Mark's grad student. All right, so maybe leeches is not your thing. That's okay. We have lots of areas of science. And our next 2 scientists are ones that love a mystery. And if you love mystery novels or puzzles, this might be the way to go for you. They like digging into the past of living things to try to figure out what life was like a long, long time ago. And our first scientist actually loves caving and loves studying plants that are not just the plants you see today, but plants that lived thousands and thousands of years ago. Please welcome Hannah Morris. On stage is another scientist that's fascinated by life, ancient life that's been found in swamps. So going to swamps and learning about our past. Please welcome Becca Peixoto.
All right. Thank you, guys. You guys having a good time at the Science Festival? Yes, we are too. We're having a lovely time. So I'm Hannah.
And my name is Becca, and we are archaeologists, and we have really cool jobs.
So before we talk about archaeology, we just want to make sure everybody's on the same page about what exactly it is. So we have some questions for you guys. And I want you guys to yell yes or no just as loud as you can when we ask you these questions. So the first question, are you ready? Yeah, deep breath? Okay. First question is very, very important. Do archaeologists study dinosaurs?
I heard a mixed set of answers out there. Paleontologists study dinosaurs. And there's some similarities between archaeologists and paleontologists. We both like to dig in the ground and find really old stuff. But archaeology is part of a field called anthropology, which is the study of people and cultures. And archaeologists look at people in the past through the things that they left behind. So, do archaeologists study trash?
Yes. Great, we actually do study trash. And it's old trash, which means it's even more cool. So we, as archaeologists, we often study things that people either lost or they threw away. So these can be things like an arrowhead or a piece of a ceramic vessel, maybe, or it could be kind of waste food items like a corn cob. This is actually what I study. I study plant remains from archaeological sites. So I'm interested in what kind of plants people were eating in the past and what they were doing that changed the vegetative landscape around them. So how many people ate a plant today? Did you guys eat your vegetables? Yeah? Okay. How many people have ever made a campfire? Yeah? Okay, well, people did all of those kinds of things in the past too, and that's what I'm trying to understand. So right now I work on an island off the coast of Georgia. And I'm studying a site where some of the first Europeans who came over to the New World built a Spanish mission in the 1500s. What's really, really exciting to me and really cool to me is that when those Europeans came over here, they brought a lot of new plants with them.
My research is on larger things. Some archaeologists study really small things like seeds, like Hannah does, and others of us look at vast landscapes. I work in a place called the Great Dismal Swamp, which is on the border of Virginia and North Carolina, and we are researching a group of people called Maroons who escaped from slavery in the 1700s and 1800s and went to live deep in this remote area in this really inhospitable place called the swamp. And I use chemistry and physics to look at little tiny pieces of glass that the Maroons left behind on their islands in their community in order to figure out how they formed a community, what they did, how they made their lives, and generally what life was like in the swamp so long ago.
All right, so maybe you guys are wondering how Becca and I ended up becoming archaeologists. Well, as you can see from this video, my career as an archaeologist started at a very early age. When I was a kid, I loved playing in the dirt. I loved being outside. I loved learning about rocks and minerals, and especially collecting fossils, which is kind of similar to what I do now. Now, as you can see, I also love getting dirty, and if you're an archaeologist, you really have to like dirt. So this next picture, this is a picture of me coming out of a cave. You can see I'm pretty dirty.
I'm not very good at staying clean either. This is me on my way to work in the Dismal Swamp. Before I became an archaeologist, I studied math, I studied history, I studied linguistics, and I also was really into rock climbing and backpacking and spending a lot of time in the wilderness. And I get to use all of those things together in my work as an historical archaeologist to explore, to dig in the dirt, to do some really great science, and to try to answer lots of questions and solve mysteries about people that lived a long time ago.
So Becca and I do a lot of historical archaeology. Most of the time we only work on sites that are maybe a few hundred years old. But recently we got to use our skills and training as archaeologists and kind of outdoorsy people to go down to South Africa, where we were excavating some early hominin remains from inside a cave. Now these were remains of early human ancestors.
So last year, some South African cavers went into a cave that's 30 meters underground. So that's 3 times the distance from this floor to this ceiling above the stage, 3 times that far underneath the surface of the earth. And in there, they saw a few bones laying on the ground. So Hannah and I were part of a team that went deep into this cave to excavate more fossils. And if you look out into the into the seats right now, there's some spaces that are lit up, maybe? Yeah, there we go. These little spaces here, that's about the area within the cave that we excavated, so not very big. And in that tiny area, we found 1,500 fossils in an area the size of those lights. And the chamber itself is a couple times larger than that, and so we think that there's a lot more material to be recovered in there. We're pretty excited about it.
Yeah, so we have a short video that we want to show you guys. It's just going to give you some visuals and maybe make it clear what life was like for us when we were down in South Africa on this expedition.
So you can see we had a little tent city set up. There were a lot of people involved in this expedition. There were Hannah and I and some colleagues that were excavators. There were cavers there for safety. There were specialists in fossils, lots of other scientists that came to help us out. So you can see here that we're walking in through the cave, and there's stalactites and stalagmites. It's a really neat cave. Sometimes things get a little tight. We'll talk about that a little more in a minute. To use some ropes to move around. There's Hannah there trying to figure her way through a spot. And we also had a control center, so we were under the ground, and lots of other people couldn't come into the cave with us, so there were cameras installed so that people could watch everything we did the whole time, moving through the cave and excavating the fossils. And see, so this is what the fossil chamber looked like when we first arrived. Those little white specks that are on the screen, those are all fossils. So we saw the fossils, and sometimes we would flag them. You'll see that in just a second. There we go. We're flagging the fossils. We'd collect them, record them really carefully, and then bring them up to the surface, often to much cheering because it's quite exciting. And here you can see some of the scientists doing some analysis and taking pictures of the fossils once they came out of the ground. And that's Hannah and the rest of our excavation team.
All right, so maybe from that video, you guys got a little bit of an idea of what it was like to be in the cave. Getting to that final chamber where the fossils are located, it's not easy. It's almost like an obstacle course. So when we enter the cave, we go through these long hallways, and then we have to go down some ladders, and then we get to a place called Superman's Crawl, which is kind of a tunnel. It just looks like a little hole in the ground. And it's called Superman's Crawl because if your shoulders are kind of wide, you have to put one hand behind your back and then point the other one up here to get through. Now, after you get through Superman's Crawl, you're at the base of Dragon's Back. That's where you saw all the people with ropes. That's when we put on our harnesses and we climb 20 meters up Dragon's Back. When we get to the top of Dragon's Back, we're actually at the top of the chute.
Yes, and can we get our chute out here, please? Here it comes. Great, so the chute is only about 18 centimeters wide in one spot. So if you have in your program, there's the Cool Jobs flyer. The length of this flyer right here, I see a few people with it out, this length right here is 18 centimeters. It's about 7 inches. So if you take a look at that and kind of compare it to your body, figure out if you think you can fit through an 18 centimeter gap. That's this gap right here. And if you think you can fit through that and you'd like to give it a try, we need a couple volunteers. And our ushers are going to help us out on this. Where's our ushers?
All right, lots of excited volunteers. I think our ushers are bringing down a few
Ushers are bringing us volunteers.
All right, how about right here?
Come on up.
And then where's our other usher? Over here? Where's our other usher?
We have another usher with another volunteer. But yeah, come on.
We have one more? Okay.
Great.
Great. Excellent. And what's your name? William. All right, William. I'm Hannah. Yeah, let's give him a round.
Kelly? Nice to meet you, Kelly. Come on over here, Kelly.
And what's your name?
Joel.
Joel? All right.
All right, and this is Kelly.
Excellent. We're going to give you guys hard hats, and you guys are going to go through Superman's Crawl.
All right.
All right.
Okay.
Kelly, you want to go
Kelly,
first?
you want to give it a try? So you can go in this way and see if you can get out the other end.
All right, and at the end we have our 18 centimeters.
It's okay if your helmet falls off.
Yeah. All right. I think we have a video we can play of some other animals going through small spaces.
There we go.
Yeah. All right. William, are you ready? Oops. Yay.
Hey.
Good job. Good job. Oh. Almost there. Almost there. Oh, get your helmet.
You get it? Nice work.
All right. Excellent.
And all of that turning around in the middle, we had to do that in the cave too. Sometimes you didn't start off, you didn't end up the same direction you started. There you go.
Oh no, he lost his helmet. It's okay. Yeah, push it through ahead of you. Great.
Take it in the cave with you. There you go.
All right, let's give him a round.
Nice.
You guys would be fantastic in the cave. All right, so at this point, can we have our box out? We're going to ask you guys to actually help us excavate, because we've gone through Superman's crawl, and we are now in the final chamber where all the fossils are located.
Oops, sorry, Hannah. There we go.
Over here.
All right, so come on over. What we have here, Kelly, you want to come on this side so all the folks out there can see? So what we have here is a box that to simulate excavating these fossils. Now, we could just reach in and grab them, but if we did that, the fossils might break. These are all casts. They're replicas of some fossils. So we have some of the tools that we use down in the cave with us. We have, what are these?
Paintbrushes.
Yeah, we have paintbrushes, and then we have some wooden, what did you call it?
Skateboard.
Sure, some wooden tools here for us to use. So would you like to try a paintbrush? You want to try one of these? You want to try a paintbrush or one of those? Okay. So let's see if you can find some fossils in here. There we go. Nice.
Working away on some of them.
Yeah.
Oh,
Oh, oops. We got one.
Yeah.
Awesome. All right. So we have 2 of them here. That's great. We'll leave that one for just a second. So we have 2 casts here. Do you think you know where this goes on your body? What bone is this? It is. It's a mandible. It's your jawbone. And then we have another one that's a little trickier here. What about this? Anybody? Thigh? No. Hannah, you want to? Oops.
Any ideas for that? Clavicle.
A clavicle.
Who said
Good
that?
work.
Good job.
Nice.
Exactly.
Yep. So
That's your
here.
collarbone.
Yep. And we have one more piece, and this will be the last one.
Pelvis.
You're right.
Exactly.
That's right. We're going to leave that one in there for now. Okay. Cool. So can we give our volunteers a hand? Thank you very much for helping us.
Great job. You guys excavated some bones.
Yeah. Great.
All right, thank you. If you guys want to step down.
Which way you're supposed to go?
Either way is fine. Great. Thank you again.
So I love my job. I love being an archaeologist. There's lots of adventure. I'm outside. I'm not in a cubicle on a computer all the time. I also like my job because I get to work with a lot of other scientists. I have a specialty in archaeology. Hannah has a specialty in archaeology. There are scientists that focus on bones, on rocks, on plants, on all kinds of different things. And working together with other scientists, we get to try to solve mysteries and answer questions about people whose histories aren't written down and who otherwise we wouldn't know anything about. And we only get to do that as a team. And I really love that about being an archaeologist.
I also, of course, love being an archaeologist. I just think it's the most fantastically cool job. I would never want to do anything else. Now, it's really fun to do science and to try and answer these questions about how people used plants in the past. But I also really love my job because it's kind of like a treasure hunt. I get to just go outside and wander around in the woods all day long, and I never know what I'm going to find from day to day. So, we hope that you guys have learned a little bit about archaeology. We hope you're excited about archaeology because, let me tell you, there are a lot of archaeological sites left in the world, and we need more people just like you guys to come help us excavate them. Thank you.
All right, give it up for Hannah and Becca. All right, so this summer, kids, when you come in and you're covered with dirt, and your mom goes, "Look at you, you're filthy," just go, "No, I'm a scientist." All right, well, maybe going deep down underground isn't your thing. Maybe you're looking for something a little higher up in elevation. Well, how about if your office was 350 miles above Earth, traveling, I don't know, say 17,500 miles an hour? If that sounds just a little bit interesting, I've got great news. We have a for-real-life astronaut here Please welcome astronaut Mike Massimino!
How's everybody doing? You sound like you're still awake, which is a good thing. Hopefully you'll still be awake in a few more minutes, too. I don't even know if I need to say it's a cool job, but it is a really cool job. I know you've heard a lot from these other scientists, and I think what's interesting when I was listening to them is how passionate they are about what they do. And so what I'm going to tell you a little bit is a little bit about my journey to become an astronaut, and then what my job is about, and the cool things I get to do as an astronaut. Just actually, I'm only going to be able to tell you a little bit, just a portion of the cool stuff I get to do. But what I would like, especially for our young people to realize is that you need to figure out, or you need to figure it out, but dream at least about what you're passionate about. And if it's involved with math and science or engineering like it was for me and the other people that have spoken to you today, then you should pursue it. And it might not be easy, because learning math and science in school was very difficult for me and wasn't always smooth. But it leads to really cool lives. I mean, I've enjoyed my life immensely. I'm going to try to express that to you. But it's not easy, and there's a lot of ups and downs with it, but you need to stick with it. But decide what it is that you like. You can hear a lot of examples, but try to find what your passion is, what you really love to do, and then pursue it, and don't give up while you're on that journey. So those are some of the things I'm going to try to show to you from my experiences through a couple pictures I'm going to show you in the next 15 minutes or so. Okay, so we'll get started here. Does anyone know who this guy is? It's not me. Someone said me. No, it's not me. This is actually Buzz Aldrin. The picture was taken by Neil Armstrong. So I'm looking at the kids out here. You look like you're kind of like maybe some of you in elementary school, junior high, sort of. So I was 6 years old when I watched this happen on my TV set in 1969. And I was in New York. That's where I grew up on Long Island. There were two things going on. Neil Armstrong walked on the moon, and the Mets won the World Series. And that more or less, there are more Mets fans here than at Citi Field. Actually, they're not playing in Citi Field today, and we might not even know the difference in the parking lot. But that's another story. I grew up in New York, so baseball and space are my two passions as a little boy. And I saw these guys walk on the moon back then in the late 60s, early 70s, and that's what inspired me. I said, how do I do that? I had no idea how it was going to happen. But I was like, that's the job I want. And so what I did was, that is me. That's in my backyard, probably about 2 weeks after Neil Armstrong walked on the moon. That's a converted elephant costume from the kindergarten play I was in earlier in the year. And that's me dressed up as my hero, Neil Armstrong. But that's what I wanted to do when I was a very little boy. Can people tell me what this is? What we're looking at from space? That's New York. I'm not an astronomer here. I know there's a lot of astronomy people. But I think in astronomical terms, this is the center of the universe right here, okay? That's where we are, New York, center of the universe. I grew up kind of to the right. We're kind of in the middle of the picture there in Manhattan. I grew up to the right in Long Island. But when I was the age of most of the kids here, I did not think about being an astronaut. That was a little kid dream that kind of went away. I went through high school and enjoyed math and science and found out that engineering might be something I'd be interested in studying because it was kind of like the applications of math and science. I got lucky enough to go to Columbia University, worked for a couple years as an engineer after graduating, and then I started thinking about what I really wanted to do with my life at that point, and it was the space program that kept coming up in the back of my mind. So I went to grad school up in this area. This is a picture from space of Massachusetts. You can see Cape Cod going off to the right. So I got very lucky and had a chance to go to MIT and started pursuing my application to be an astronaut once I was in graduate school. So I applied while I was in graduate school. I was qualified to apply after I got my master's degree, and I sent my application to NASA, and you know what they told me? They told me no. So I had to wait a couple years, and I applied again. But then after a couple years, I had gotten my PhD from MIT, right? Big deal. So I put my new application in, and guess what they told me then? They told me no. So then I, in fact, actually went down in my ranking, and it was a lot of good that did me, right? So I did a couple years of going by, and then I moved to Houston. This is the Johnson Space Center. This is where astronauts train down in Houston, Texas, really south of the main city of Houston, down in Clear Lake. But to me, this was the place I wanted to be. If I couldn't be an astronaut, I wanted to be working here, helping people go to space. So I got to know a lot of the astronauts. I worked for a contractor at the Johnson Space Center. I put in another application. I got an interview. So they got to know me very well. There's only about 100 people get an interview. They got to know me real well, and guess what they told me after that? They told me no. So, I know life was going on. I was, people have coming out with their kids. I do have kids, but they've heard me talk so much they don't want to hear me anymore. So I was impressed that some of the other speakers had their kids on stage. No, it's okay. It's a joke. My kids, it's all right. It's okay. I moved to Atlanta. I got a job at Georgia Tech. So I moved from Houston to Atlanta, but I kept applying. I wasn't going to give up my dream. This is Atlanta from space. That really green line, this is night, of course. That green line is our atmosphere, just to give you an idea of how thin our atmosphere is. It's kind of like the top layer of an onion. You think of the onion as our planet. So it's very thin, our atmosphere, but it's very beautiful, and it comes up green at night. It's just spectacular. So anyway, I applied again when I was in Atlanta and got another interview, and this time they told me yes. So after my fourth try, I got picked. Thank you. That was in 1996. So I tell you that story because things don't always work out the first time. Okay, and scientists can tell you this too. The first time they try something in the laboratory or they try an experiment, it might not work. And for me, just about nothing works the first time I try it. And I think that that's okay. I think the important thing is that you don't give up, okay? So that's why I tell you that story, is not to give up if you're trying to pursue something, particularly if you're trying to pursue a dream that isn't so easy. You got to recognize, hey, this is not may be so easy. I might have to tough it out. And that's what I did, and I got lucky. And I'm on the second row from the top, third from the left. My hair's a different color than it was back then. I went to my 30th college reunion, and one of my friends, so he goes, oh, you look just like you did in college. I go, when I was 18, I did not have white hair. I do not look the same. So that was me back in 1996. We got to do some real, so this is now the cool part of my job. So I'm going to talk a little bit about flying in space, but we do a lot of cool stuff while we're on Earth. And one of them, I'm going to tell you just a couple of them. There's lots of stuff. But one of them for me was getting to fly in a T-38 aircraft. I was a private pilot, but I'd never been in a military airplane before, especially one like this, which is really cool to fly in. This is a picture of me in the cockpit, and thank you. So this was taken, it was a National Geographic documentary, and they had these GoPro cameras. This was a still that they sent me with this photo. And we get to fly in space just every couple years, but you get to fly in this airplane as much as you want, pretty much, for your training. About once a week, I got to do a training flight. And when I was looking at this photo, when I first got it, I was saying, what am I? Because I was looking at my visor. Like, see, below me is like blue, like the sky, and above me, you see in the reflection of my helmet, is like looks like land and a cloud deck. So really, what I figured out is I was like this. I think we were at the top of a loop at about 24,000 feet, going about 500 knots, upside down. Is this a cool job or what? All right. I want to talk a little bit about spacewalking, and then I'll show you some stuff in space. We're going to do a demo here. This is me working with some astronaut gloves on and a power tool that we helped design to do a job to repair an instrument on the Hubble Space Telescope. There were 117 small screws that needed to be removed from this instrument. I had to remove a handrail first to get to this point where I could put this piece of equipment on there to remove all these screws to repair the instrument inside. So we practice things like this over and over again. It's a big team effort. We have instructors, we have tool designers, we have our crewmates to work on, and we have a singular job to do, which is, in this case, was to repair the telescope. So we practiced endlessly together how we were going to communicate every move we were going to make. We did it before we got into the water tank, which I'm going to show you now. we would practice this stuff on land, and then we'd go in the water and practice the whole spacewalk. On my missions, we had 5 spacewalks, which is a lot of spacewalking. We did those 5 days in a row. We had 2 teams we would alternate. So we would run those spacewalk scenarios Monday to Friday in the pool, just like we would in space. And those days were great. You know, we'd wake up early in the morning, get out to the pool, get checked out by the doctor, get in your fancy spacesuit clothes, get loaded into the water, and then run your spacewalk from start to finish up at about 4 o'clock in the afternoon, take a shower, debrief, get ready to go home and say, boy, I can't wait till I get back tomorrow. That's how much fun it was doing this stuff. Right now what's going on, it's kind of bright in the pool. That's me on the left. Mike Good Bueno, my buddy, is on the robot arm on the right. These scuba divers are holding a big silver thing. It's a camera. It's an IMAX camera. They made an IMAX camera, an IMAX film from our flight, and they used some of the footage that they took that day in the pool to make that movie. But that's us practicing fixing the Hubble. Here's my crew. I'm going to talk to you a little bit about my second flight into space. We're doing a training exercise in an armored personnel carrier down. It's an emergency thing we were doing down at the Kennedy Space Center. They took a photo, and I kind of like this photo. Driving the tank is Megan MacArthur. She's an oceanographer. All of us had really cool jobs before we became astronauts, but we gave them up for the even cooler job. So Megan was an oceanographer, and she was our flight engineer and robot arm operator. She's in the front driving the tank for us. We would all pile in the back. She would take us to safety was the idea. John Grunsfeld, who I think spoke earlier in the program a couple days ago, he's on the left. He was our lead spacewalker. I'm just to the right of him. Below me is my spacewalking buddy, Mike Good. Greg Johnson, our pilot. Then to the right below is Drew Foysel, who's a geologist, became a spacewalker. And then Scott Altman, our commander. We launched on May the 11th 5 years ago. You go from 0 to 17,500 miles an hour in 8.5 minutes. It's a lot of power, acceleration, speed. It is a really cool ride into space that you take. We got to the Hubble a few days later. We rendezvoused with it, grabbed it with the robot arm, and then we got to spacewalk. And so this is a picture of me spacewalking, handling a solar array. So you work with really cool tools. You're inside of your own spaceship, which is your spacesuit. And just over your shoulder at any minute is the most beautiful scene you've ever seen. Seeing the Earth from space at the Hubble altitude, you can see the curvature of the Earth. It takes up your whole field of view, but it's just magnificent. No words can describe how beautiful it is or how beautiful our planet is. So I'll just tell you what my first impressions were when I got to look at it from my spacewalk, when I didn't have a window in front of me. I could look anywhere I wanted. And that is when I saw a scene like this, what went through my mind was, if you were in heaven, this would be the view. If you could go to heaven and look down on our planet, that's what you would see. And then it was replaced by another thought, which was, no, it's more beautiful than that. This is what heaven must look like. It's like looking into paradise. So my job is cool because not only do I get to go fast, work with really cool tools, but I also get to view things that are the most beautiful things that I can't imagine anything more beautiful than what I've gotten to see while I'm floating around the planet. This is a picture of us going from darkness into sunlight. Since we're going so fast in space, we get 45 minutes of sun followed by 45 minutes of darkness, 90 minutes for one lap. You get 16 sunrises, 16 sunsets in one day. And you can see the line. When you're spacewalking, one thing you can do is when you can kind of feel the heat of the sun coming, take a look at the planet. You can see the sun out in the distance as our stars out there. And what you realize is that date line, that difference between blackness and light is moving. And that's a sunrise on Earth that you're watching. And what hit me was that I'm watching the revolution of our planet. I'm watching the planet move. You know, you really think of the sun is coming up and going down. That's not what's happening. That sun's not moving. I've seen it. The sun's staying right where it is. We're the ones that are moving. The planet, you know, we're zipping around the planet in space, but that thing is moving. And I kind of got the sense when I looked at it that it's not going to stop moving anytime soon. So the sun will come up tomorrow. I can guarantee it. I had trouble with those 117 screws I needed to take out that we practiced. I was having trouble one bolt. I actually stripped the bolt. Do I look happy in that picture? No, I'm not very happy. So I was getting some extra tools. The solution came up after about an hour and a half just to rip the handrail off, that worked actually. I would have never thought of that on my own. A young engineer from the Goddard Space Flight Center tried that on the ground while we were spacewalking, radioed it over to Houston. They sent it up to us. We said, yep, we can do that. Bang, it came off, fixed the instrument, it was fine. But I was not happy before I knew what we were going to do, because I thought we were not going to be successful that day. But I was happy at the end. So that's me at the end of spacewalk. So I think we've talked a little bit about training and what we do in space. I'm going to bring my friend out, Harrison, who's going to help me with a demo on spacewalking. He's all dressed up. You all right, man? All right. Okay, so we got this wire coming down. We actually do this sort of stuff. I showed you the pool, right? Remember the big picture? So the pool is really big. It's 200 feet long, 100 feet wide, 40 feet deep. We get in our spacesuits and practice our crew coordination, all that. And but you're kind of slowed down by the viscosity of the water. It's not exactly like moving in space. So they do this kind of stuff to us. You doing all right, man? All right. If you have any trouble, you let me know. So what they do is they do hang us from wires like this, like Peter Pan, because this gives us a little bit of a different experience. If he were to push off, it's for me, right? There you go. He goes flying. You don't want that to happen when you're in space. So you learn how to keep yourself stable and do your work. So one thing we would do is, Harrison, I'm going to grab your feet, okay? So you always want, if your feet are nice and stable, then you're going to stay in one place, and you can do your work. So go ahead. You want that? I'm going to give you this. Okay. Let's keep it out of my face a little bit. There we go. All right, here we go. All right. So he's got a helmet on. I don't. So I can get hit with that thing. So, so he's not doing something that's very easy. We were practicing this early. It's not easy. Can you think of why? Why is it? It's harder for a couple of reasons. One is that he's not as stable as he'd like to be. I mean, I've got his feet, but he's floating, and all this stuff is floating. If he were doing this in space, he'd have this stuff attached to a tether. So if he drops this, it's going to go to the floor. You got it in there. Congratulations. You want to try this other one? All right. Okay, see, that's what happens with gravity. Here, try that again, man. We'll keep working. So in space, you would want to have that on a tether so it wouldn't float away from you. And he's also working with gloves on. So I describe spacewalking, working on the Hubble, is like working on your car, except you're doing it with boxing gloves on. So you have to design the tools a certain way so that they're easy to use. You don't want to lose anything, so you need tethers, you need hooks and things so you won't lose your stuff. You got to keep track of everything and be very, very particular on how you work. He's got a suit on, which is also not the easiest thing to work inside of. Our spacesuits give us some extra pressure. You have to fight against that pressure to do your job. But he's got it this time, I think. So we're going to call victory. But this is just to give you an idea of some of the things we do. You doing all right there? You want to try this other one? All right, okay, I think we're going to get Harrison down. You ready to come down? All right, I think we're going to call it quits. All right. So, all right. All right, so we got to do some really cool stuff. Do I have a couple minutes left here, I think? All right, we're going to go to this next slide. This is a slide from Hubble. It's not the most famous Hubble image, but it's one of my favorites because it was the first one that we saw after we fixed the telescope, which told us that the telescope was actually working correctly. This is Omega Centauri. We're looking at 100,000 stars in this one spot of the sky, and that's within a cluster that has nearly 10 million stars. And the stars are about 10 to 12 billion years old, and they're 16,000 light years away. So one of the, I think, impressive things about the telescope, it's not only an engineering wonder that can work and point itself and get these images, but it also bridges engineering, which I'm an engineer, with science so that scientists can make great discoveries. I've got a video to show. We got time for a video? Who's in charge of this operation here? Okay. This is just a quick video about eating in space.
That's Megan MacArthur.
So Megan, you can see Megan's hair. Everything's floating, including her hair.
Well, we just
and
finished the starboard survey.
I'm asking her what she did, and she's going to show. She's opening up her locker,
I go to this locker here that says MSC.
and she's going to get a bag of food out.
It shows me all the food with the green
See, that's all of her food.
that's in here, so I look up kind of what I want to
And that's ravioli in a bag, okay? And then you're going to see a couple more seconds. This is my friend Drew making a sandwich. All right. Is that a cool job or what? All right. So I'm going to leave you alone now so you can enjoy the rest of your day. But I would like, especially the young people here, to remember a couple things. One is that whatever it is that you find that you like, whether it's you're dreaming about being an astronaut or an astronomer or a mathematician or an archaeologist or an anthropologist or whatever we've heard, or a writer or a teacher or whatever it is that you might want to do, I would encourage you to pursue it with all your heart. You have to be true to yourself. It may not be the easiest thing to do, but if it's what you want to do, you got to give it a shot. So I want you to dream about what you want to do. I want you to think big, aim high. You know, if you're interested in being an astronaut, try to be an astronaut. If it doesn't work out, you can do something else. But I would aim high. Don't settle for second best. Do as well as you can. And the third thing is never surrender, okay? Don't give up. Don't give up your dream. I had to apply 4 times. What I didn't tell you about is my academic career, which was not always smooth, all right? I started with 8th grade earth science. I got clobbered, okay? And I really had to figure out a way to work harder in 8th grade. And it happened to me at different times in my education, going all the way through grad school, and even as an astronaut, trying to learn stuff as an astronaut. It never stops. You're always going to take your lumps. It's hard, but don't give up. Have a great day.
Mike Massimino! I don't know about you, but I could so go for a space burrito right now. All right. Well, just to kind of echo what Mike was saying, hopefully, how many of you guys got inspired by some of these cool scientists today? Unbelievable. Unbelievable. Yeah, bring it out, guys. Yeah, like we said, whether you like animals, whether you like digging in the dirt, whether you like aiming high into the sky, there is something for you out there, and find a way to pursue it. Now, as for me, I want to give you one last kind of interesting tip about being a scientist, and that is that scientists have access to really cool stuff. You got lasers, you got robots, you got telescopes, or in my case, liquid nitrogen. So, with your permission, I'd like to do one little demo. Is that okay? All right, good. Excellent. So, liquid nitrogen, I love liquid nitrogen. It's really cool. So when you take a breath, actually about 90% of what you breathe in is nitrogen. It's a gas. But if you compress that gas, it gets really, really, really cold. And so cold, it drops down to 321 degrees below 0 Fahrenheit. I'm going to pour this in here, and you can immediately tell it's kind of cold. Yeah, this is World Science Festival. Let's do this. All right, there we go. Now, I've also got a container of something that's very hot, a bucket of boiling water. There's a difference between the two of about 500 degrees. When I add the two together, 2 things should happen. 1, I'm going to vaporize the water, and 2, I'm going to condense the water. And if all goes well, we should get a little cloud. Wouldn't that be nice? I think so. All right, so let's wrap up our little program with a final demo. Oh, this is fun. All right, here we go. I'm going to need your help. Would you count me down from 10, 9,